mencapai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, salam sejahtera dan good evening everyone. Welcome to Pusat Tuisyen Akademi Youtuber with joint venture of EDD Malaysia and Guru Malaysia. Bermula percuma, selamanya percuma. So I'm Mr. Peh. Currently I'm teaching at College Tingkatan 6 to Fatimah Melaka. I'm the teacher on duty for this week. And today we are going to continue our chapter 2 with the subtopic as atmospheric pressure. So you'll take about 1 hour to complete the lesson today. And for information in this week, we are also have 2 classes of physics. So for Form 4 physics, for non-DLP class will be presented by teacher SlindaNordin. And the topic she was presented this Friday, okay, is actually gerakan jatuh bebas. Another class will be as usual conducted today's every Sunday, 8:45 p.m. Okay, so the link of the e-certificate will be provided at the end of lesson. Okay, so you need to fill out the form before 30 minutes of the lesson end, and the link will be provided when the lesson end today. You can actually fill out the form with any email you are available. Okay, so without further ado, let us start our class today. So basically today we have about 4 learning standards you are going to learn. So the first will be describe atmospheric pressure. Okay, so firstly, you need to define atmospheric pressure. Okay, so the definition for atmospheric pressure is the pressure due to the weight of the layer of air acting on the surface of the earth. Okay, so you can just illustrate it in this figure. Okay, so where the atmospheric pressure is added uniformly in all directions. Okay, so the earth is surrounded by a thick layer of the air, consists of various types of gases. For example, carbon dioxide, nitrogen will be the majority, and also others. Okay, so this will be represented as this blue color layer surrounded by earth. So this layer we know as atmospheric pressure, atmospheric layer. Okay, so this layer has weight and assess the pressure on the surface of the earth as well as all objects on it. So you can see here the air is actually consists of wet. Okay, so and added to the surface of the earth, just like the arrow showing in this GIF. So therefore, all objects on the surface of the earth experience atmospheric pressure. Okay, so as per definition just now, we mentioned, so atmospheric pressure is the pressure. So when we actually learn already with the formula F over A. Okay, so the unit SI will be Pascal or Newton per meter. Newton per meter square. Okay, so that means that the weight here is actually force. Okay, so force or gravitation. Okay, so added at the certain area or unit per unit area. Okay, so we get the pressure and named as atmospheric pressure. Okay, so this is the existence of air pressure where you actually learn already during Form 2, Chapter 8, which is also force and motion. Okay, so you can see this figure. So even when the hand supported, the car is removed. So initially, the hand is supported at the bottom of the cardboard. Okay, so the water in the glass does not flow out when the hand is removed. Okay, so why? This is because the atmospheric pressure added outward, which is here. Okay, so presence on the cardboard. This atmospheric pressure is able to support the weight of the water in the glass. So that means here the atmospheric pressure is greater than the weight of water. Okay, where is filled in the glass, so that the cardboard is not dropped after the hand is removed. And this phenomenon able to showing that the atmospheric pressure is added at all directions. Okay, so besides that, here you can see in this experiment, so where the test tube is filled with water and inverted and then immersed in the beaker filled with water. So you can see the observation here, the water will not flow out from the test tube. You can see the water is still fully filled in the test tube. Okay, so this is because the atmospheric pressure, so here represent as air pressure here lah. Okay, so prevent the water from flowing out of the test tube. So again, this showing that the atmospheric pressure is actually surrounding us and added at all directions. Okay, so there is no air in the test tube, so there is no air pressure inside the test tube to push down the water in the test tube. Okay, so this is why the water is not flow out from test tube. So this too is the example I want to show you that the existence of air pressure is actually surrounding us and added at all directions. And actually, you already learned. I just want to recall back, okay, where you learn at Form 2 science. Okay, then the next, we go to our learning standard 2. Okay, so communicate about the value of atmospheric pressure. So here, you need to know, so how we get the value of atmospheric pressure by using different apparatus. Okay, so firstly, the value of atmospheric pressure. So how we measure the atmospheric pressure? Okay, so here it will be the first apparatus or tools we want to discuss. Okay, so this is a mercury barometer, or we can also know as simple barometer. Okay, so from this figure, you may see that the as I told you just now, okay, so the value of atmospheric pressure can be measured by using mercury barometer, and we can also know as the simple barometer. Okay, so the apparatus involved will be, we need to have 1 meter long tube. Okay, so it will be this 1 meter long tube with containing of mercury. So initially it's fully filled with the mercury before the lid is opened. Okay, and then initially the glass tube filled with mercury and covered with a lid. So here we have a lid or a valve to close the mercury. Okay, so the glass tube is inverted and covered and is immersed into the bowl of mercury. So that means initially we close the valve or lid here where the glass tube is fully filled with mercury, and then we immerse into the dish here. This is can known as dish. Okay, then the next step will be when the lid is removed. Okay, so that means we open the valve, or we just removing the lid if you're using the lid now. So the mercury column in the glass tube will fall until a certain height and remain at the height. So you can just look at the GIF when inverted. You can see So the mercury will be falling down where inside the glass tube, and then it will be stop or remain at certain height. Okay, so why? You can just look at the figure or GIF here. Okay, so the force of gravity will be pull the mercury out, and then the atmospheric pressure will be added to the surface, okay, to the surface of mercury at the dish, so to prevent the further fall of the mercury. Okay, so the atmospheric pressure act on the surface of mercury, as I mentioned just now, okay, in the bowl or dish, supporting the mercury column. Okay, so the next, the vacuum space above the mercury column does not access any pressure on mercury. So you can just look at the figure or GIF. So when the mercury is fall, okay, it's fall out from the glass tube. So the empty space here is actually vacuum. So there will be no any air is trapped, and that means no collection of air particles against the wall of the glass tube. So that means no any pressure will be added. So we will measure about the atmospheric pressure actually. Okay, so the height of mercury column depends on the magnitude of the atmospheric pressure. Okay, so here you can see the value of atmospheric pressure stated in terms of height of the mercury column. So that means here is 76. If I say you follow the bottom GIF, you can see, so the mercury will be fall and then maintain a certain height, and you measure with ruler. Okay, so there will be about 76 cm. Okay, so you can see at sea level, the height of mercury column will be 76 cm, so that we can indicate or determine the atmospheric pressure is 76 cm Hg. Hg because we're using the liquid here, we're using the mercury. Okay, so if I say using different type of liquid, they might give you different height because the density of the liquid will be affected the height or H here. Okay, so later on we'll discuss more about that. Okay, then the height or H here will be remain unchanged. Okay, so if I say we change our glass tube with different type, maybe the shape, maybe diameter, and then we tilted with different angle. So you can see from this figure, when you tilted your glass tube, change diameter, okay, so here will be actually not affecting the height of H. Okay, so this will be the least. Okay, so first, if we change the glass tube with greater diameter, okay, so the H will be also remain at 76. So this will be showing by here. So the height of mercury remain the same even though diameter of the glass tube is different. So you can see, we can compare these two glass tube. Okay, so it's showing same height from surface. Definitely we want to measure from surface of the liquid in the dish or bowl. Okay, so the height is always the same, 76, even though we increase the diameter of glass tube for the experiment. Okay, then second, you can see when we tilted, okay, we tilted our glass tube with certain angle, so the height of H here still remain the same. So the vertical height remain the same even though the glass tube are slanted or tilted now with certain angle. So will be remain 76. Okay, then the next, okay, so when we lift up our glass tube, will be showing by this figure. You can see, so we lift up the glass tube but still inside the mercury Okay, so this is a requirement. Okay, then another one we lower down. You can see this glass tube. So we lower down glass tube. You can see the height from the surface of mercury will be also unchanged. Okay, so and then the next, when the quantity of mercury in the tissue increases, maybe to this level, okay, so you can see the height H will be also remain the same. Okay, so basically this will be 4 changes that will also not affecting the value of H. Okay, so here the H value can be changed here. The firstly, the H will be decreases. That means will be less than 76 cm Hg when the first condition. Okay, so the air is trapped at the empty space. So just now for the experiment where we want to identify the atmospheric pressure by using mercury, we need to start with fully filled of the glass tube. Okay, so that there will be vacuum condition at empty space. So that means there will be no any air pressure added at the surface of the mercury inside the glass tube here. Okay, but if I say it's trapped air, so definitely there will be air pressure added against the surface of the mercury. Okay, so the atmospheric pressure will be actually the same, but the height will be lower because it's affected by the air pressure in the empty space here. Okay, so we expected the H2 here will be lower than 76. Okay, so as I mentioned, when there is an air, there will be the air pressure added here and causes the height decreases lah. Okay, so the next will be when you bring over your barometer to mountain, that means will be from sea level initially at here, and then go to higher altitude, such as mountain now. So the value of the pressure will be decreases. Why? This is because you can just look at this figure. So the air particles numbers will be decreases when at the high altitude compared to sea level. So that means the collection of particles against wall container decreases, causes the pressure at mountain or high altitude decreases. So this will be discussed further at the Learning Standard 4 later on. Okay, so here the conclusion will be the altitude will be increases. The altitude increases will cause the atmospheric pressure decreases lah. Okay, so you can just look at the arrow becomes smaller. Okay, and then the next here will be the height H will be increases when the barometer is slowly submerged in water. So that means when we change the liquid, okay, to water, so you can see the height will be changes lah. Okay, so the height will be changes as the density of the water is less than the mercury. Okay, so this also will be discussed in example. Okay, and this case is also can caused by the liquid pressure also. So this all will be discussed later on for H will be increase and decrease lah. The reason, okay, will be discussed detail at 2.4 at Learning Standard 4. Okay, so as mentioned here, the mercury will be given height of 76 cm. So we label with mercury. For water will be about 10.3 meter, and liquid we're using is water. So you can see the value is different, but actually it's an equivalent value of atmospheric pressure. Okay, so besides we can using the simple barometer or mercury barometer, so here there is an improved tools or apparatus to measure the atmospheric pressure or pressure lah. Okay, so here named as a 14 barometer. Okay, so the appearance will be just look like this figure lah. You can just get the figure from textbook actually. Okay, so 14 barometer is an improved version of simple mercury barometer for just now one. Okay, so the value of atmospheric pressure is determined by changes in the height of mercury column. So that means they're using the same theory. So the height of mercury column indicate the value of pressure lah. So when the pressure increases, so the column or H here will be higher. So this apparatus or tools is using the same theory with the simple mercury barometer we just now explained together. Okay, so usually used to measure atmospheric pressure at the meteorological center. So this is the place where they're using this tool to measure the atmospheric pressure. Okay, so the advantage will be, first, it gives more accurate reading of the atmospheric pressure because a vernier scale is used, so you can see. So the vernier scale will be here. Okay, so they can become more sensitive. Okay, so that the smallest division can be measured by this tool will be about 0.1 mm Hg. Okay, so the disadvantages for these tools will be larger in size and not portable. Okay, then will be take longer time to give a reading of atmospheric pressure. So this is the disadvantages for 40 meter. Okay, so here we have another tools. Okay, can be used to measure the atmospheric pressure. So this is a aneroid barometer. So the aneroid barometer, the value of atmospheric pressure is determined by changes of volume of a partial vacuum metal box. It will be this. Okay, it will be this. These parts we know as the partial vacuum metal box lah. So just now, the first two, the mercury barometer and the 14 barometer, we determine the atmospheric pressure by using the height of mercury column. Okay, but here we're using the changes of volume of this metal box. Okay, so when the atmospheric pressure decreases, for example, you bring the aneroid barometer to mountain, as we mentioned, so the pressure will be decreases, right? Okay, so when the pressure decreases, that means the pressure added to the box is decreases, and the air pressure inside the box is actually added more lah, right? So make it expand. Okay, so this just on the first one. So the second one, when atmospheric pressure decreases, the box will expand. Okay, when atmospheric pressure increases, so you bring to lower altitude level. Okay, so the box will be contract. Okay, because now the atmospheric pressure increases, so there will be more pressure added, okay, to the vacuum metal box here lah, or partially, here is labeled as partially evacuated box lah. It's the same names for this lah. Okay, so they will cause the box become smaller lah. Okay, so these changes or movement will be magnified by the level of system. So the level of system will be here. When the volume of the partial vacuum metal box changes, this will be magnified by this level system, which is connected to the pointer. Okay, so you can just look at this GIF lah. So when expansion or contraction of the partial metal box, okay, so this will be magnified at the level system, which is connected to pointer. Okay, so this is the theory, how the changes of volume is able to connected with value of atmospheric pressure lah. Okay, so the advantage by using these tools will be, firstly, is actually smaller and portable. Okay, so compared to just now one, the 14 parameter is actually bigger and not portable. So this will be smaller and portable, is more convenient to bring for travel or others lah. Okay, so give a direct reading for atmospheric pressure. Okay, so you can just look at the tools. Okay, so the pointer will be given you the reading of atmospheric pressure lah. Okay, so it's suitable to use in home, ship, airplane to obtain a quick reading of atmospheric pressure. So used as an altimeter by mountaineer to determine the altitude. Okay, so this will be the advantages by this analog barometer. Okay, and then the disadvantages here will be the accuracy is actually lower compared to 14 barometer just now we learned together. So here will be +1 mmHg. Just now the 14 barometer can given the accuracy up to 0.1. Okay. Okay, so we have already finished our learning center 2. So we go to our learning center 3. Okay, so it's a problem solving in daily life involving various pressure unit. Okay, so as per mentioned just now, we actually have different unit for measuring the pressure. So from the what you learned already, the pressure SI unit actually Pascal or Newton per meter square. And just now from learning center 1 and learning center 2, you know already we're using the mercury barometer, 14 barometer, and together with analog barometer. So these 3 barometer given you the pressure unit is mmHg or cmHg. Okay, so here we have to discuss again the SI unit of atmospheric pressure is actually same as others measurement of pressure. We're using actually Pascal or Newton per meter square. Okay, so how we converting the unit of cmHg, mmHg to Pascal? So let us learn together here lah. Okay, so here we have one formula where you learn already at previous subtopic 2.1 together with Cikgu Hasnitah. Okay, so where the formula we're using is a pressure equal to H rho G. Okay, so the formula of this formula we can use to obtain the value of atmospheric pressure in Pascal, which is the SI unit for the pressure actually. Okay, so just now we also learned together how we get the atmospheric pressure by using the simple parameter. So we actually using the height of mercury column to determine the value of atmospheric pressure, where we using the liquid is mercury, okay, and given the height about 76, so we come out the atmospheric pressure with unit of cmHg, and the value is 76. Okay, so here we actually can using the height where we need to converting to SI unit to become 0.76. Okay, and the density will be the liquid we use. This is the density of mercury with a value of 1.36 times 10 power 4, okay, kg per meter cube. So you can see all unit we here we use here is actually the SI unit. Okay, then we substitute to the formula. Okay, so where will be H rho G. The H is given 0.76. Then the liquid density is 1.36 times 10 power 4, and G is 9.81. Okay, then we get the value about 101,369.16 Pascal. So this will be the atmospheric pressure in SI unit actually. Okay, so besides of this Pascal, the atmospheric pressure can be using others unit. So here Newton per meter square is actually equivalent to Pascal lah. Okay, so these two values is actually the same lah, just we convert to standard form. Okay, so as per mentioned just now, we actually using the water for measure the atmospheric pressure. Okay, so the value is about 10.3 meter water. Okay, so later on I will show you how we get this value instead of using the mercury. Okay, so the 76 cm/Hg and 760 mmHg is actually we learned already just now lah. Supposed to be no any problem. Okay, so here we go to our checkpoint question number 1. Okay, so here will be the first problem solving. Okay, so let us go through the question together. Okay, so the height of mercury column in a barometer is given 756 mmHg on a cloudy day. So calculate the atmospheric pressure at the time in Pascal. Okay, just now I already told you. So the conversion between the mmHg to Pascal be using the formula rho GH or rho Hg lah. Okay, so here the firstly we get the atmospheric pressure. From the question, we need to change to meter lah. So mm change to meter, we need to divide 1000. So we get 0.756 meter Hg. So this is actually the H value lah. Okay, so then we change to unit of Pascal, be using H rho G. So we using the H as 0.756. Then the rho will be this value, the mercury density. G will be 9.81. Okay, you just substitute everything in the equation, then you get the value about 100,862 Pascal. Okay, so this will be the answer, and this is actually the question from the formative practice in your textbook. Question number 2, page 55. Okay, so this is the discussion for this question. Okay, and then the next will be question number 2. Okay, so this is a question actually I want to show you that how we get the value of atmospheric pressure by using the liquid, which is water. Just now we know already by using simple barometer where the liquid we're using is mercury, and given the H1 or atmospheric pressure about 76 cm/Hg. So how about the value for water? So we will get H about 10.3. If I say you notice the value I showed you just now. So how we get that? So I will show you here. Okay, so the atmospheric pressure can support a vertical height of 76 cm of mercury. So this is what we actually get through the simple barometer. So if the mercury is replaced by water, so what is the vertical height of water can the atmospheric pressure support? Okay, so now we want to know what is the height will be showing if we using the water instead of mercury. Okay, so here the atmospheric pressure added on both type of liquid is actually the same. Both is the same because they are at same altitude unless you change the altitude. Okay, so here the atmospheric pressure is the same. Okay, so the H1 will be by using liquid or mercury. The 2 is for water. Okay, so the H1 is given by the question, which is 76. Okay, so we change to meter, become 0.76 meter lah. Okay, so the density of the mercury is given by the question also. Okay, so here we just using whatever the value given by question, 1.36 times 10 power 4. Okay, then the G will be the same, so you can actually cancel out, right? So you'll get substitution for H1, 0.76. Then row 1 will be 1000, which is given by the question. Sorry, here suppose, I think here I wrong already. 13600. The H2 is referring to water. So here the row 2 will be 1000. Okay, so given by question. Density of water. Okay, so here will be, okay, so here also 13600. So here will be 1000. Okay, so after you press your calculator, you'll get about 10.336 meter. Okay, so this will be the height if I say using the water. Okay, you can see it's actually very high. Okay, so they will be more convenient if I say we're using higher density liquid for our barometer, right? Okay, so we can just given that the value of atmospheric pressure by using water is actually 10.336 meter water, or sometimes the question can give you as meter H2O because H2O also represented as a water. Okay, then the next question here will be question number 3. Okay, so this is actually the example question I actually take from textbook page 53. Okay, so we can discuss together. Okay, so the maximum pressure wall at the sea side can withstand is 3.6 times 10 power 5 Pascal. So this is the maximum pressure able to withstand by wall. So what is the maximum pressure in unit of meter water? Actually, this is H2O, right? I explained to you just now. The water here can be H2O also. Okay, so the question given us the value of density of water is 1000 kg per meter cube, and then the G is given as 9.81. Okay, so here the pressure, we just using the formula as we learn at subtopic 1, and I also recall you again for this formula. Okay, so here we just substitute the value given by the question. So the maximum pressure here will be this, then density of water and G given. So the H here is about 36.7 after you rearrange again your value. Okay, so the pressure will be 36.7 meter H2O. So you need to give meter H2O for the maximum pressure you need here. You say given meter is wrong. Okay, so we need to know what is the material or liquid you use. Okay, because the different liquid here will be giving you different heat. Okay. Okay, then the next will be the question number 4. Okay, so calculate the pressure on the trapper A in each case. Okay, so just now we know already from the discussion. So the existence of the air pressure in the space supposed to be vacuum in mercury barometer. So there will be decreases the reading of the atmospheric pressure. Okay, so here we need to see the position of the test tube. Okay, so here as we know already, the atmospheric pressure is added at all directions. So that means including here. So this will be atmospheric pressure added. Here we have opening. Actually, it's added everywhere. Okay, so here the atmospheric pressure is added at this position. Then the mercury column is here. So the weight is actually here. So that means you can see the position, in this position, the weight of the mercury is not affecting the atmospheric pressure added. So the H or the atmospheric pressure here will be actually same value now. Okay, so here, as I mentioned, atmospheric pressure will be adding on all directions. So the air pressure here is actually same as atmospheric pressure. Okay, so the answer, the air pressure will be 76 cm Hg. Okay, so here, if the position of the test tube changes, you can see again the atmospheric pressure is added at all directions. So that means it will be here lah. Okay, so again here we have the weight of the mercury added per certain unit area. So that means here we have another pressure added here. So the overall air pressure will be plus 20, the height of the mercury here. So the total air pressure trapped here will be atmospheric pressure plus the mercury pressure here. So given as 76 plus 76 plus 20, so we get 96 cm mercury. Can then see, so when the test tube is inverted at this position, okay, so you can see again the atmospheric pressure added here. So now the weight of the mercury added at downward, which is opposite position. Okay, so per certain area, so that means here will be another pressure lah. So be pressure from the mercury here. So they will be reduced because of the direction is opposite here. Okay, so here will be atmospheric pressure minus the mercury pressure. So we get 76 minus 20. So we get 56 cm Hg. Okay, so this will be the calculation regarding the pressure trapped in A with different position. Okay. Okay, so before we go to learning standard 4, so we can take a break first. Then we can go for learning standard 4 and the SPM discussion, SPM question discussion regarding this subtopic today. Okay, so hi everyone, welcome back. Okay, so you may actually get my worksheet for today's lesson through the link I actually share at the chat room. Okay, will be this. Okay, and then thank you for Cikgu Hasnitah. Okay, so for joining my lesson. Okay, so you may share my link of the class to your friends so that it will be more of your friend able to benefit from my lesson today. Okay, so let us continue our last learning standard, will be learning standard 4. So here we want to describe the effects of atmospheric pressure on object at high altitude and underwater. Okay, so firstly, let us discuss about the effect of atmospheric pressure on the object at higher altitude. Okay, just now we actually introduced already. As a higher altitude, the atmospheric pressure will be decreases, right? Okay, so why? Okay, so here again, you can see the statement I already explained to you just now. So at atmospheric pressure varies with height or altitude of object above sea level. So that means the person at sea level. Okay, so when going higher altitude or mountain, okay, so the atmospheric pressure will be decreases. Okay, so at higher altitude, density and the temperature of air are lower. So you can just compare these two figures. Okay, so at sea level, you can see there are more air particles compared to the numbers of particles at high altitude. So the decreases of the numbers of particles or the density of air decreases, so may lower down the collection of the particles against the wall container, right? As this is a definition for pressure. So when the collection decreases against the wall container by the air particles, definitely pressure will be decreases. So that the higher altitude density of air decreases and the atmospheric pressure also decreases. Okay, so as a result, the frequency collection of molecule is lower. Just now I explained to you already. So the air particles will be move slower. Okay, so hence the atmospheric pressure is lower at high altitude position. Okay, so the next will be, what is the effect on the human in high altitude condition? So you can see, okay, so the person may face the altitude sickness. So what is the symptom you will see when we are at high altitude condition? Okay, so firstly, we'll be breathe faster. Okay, because we need more oxygen. As we go to higher altitude, as mentioned just now, the density of air decreases. So that means the contents of oxygen also decreases. Okay, so we need to have more oxygen so that we can gain more energy for continue to climb the mountain. Okay, so decreased oxygen contents cause the lungs to lack oxygen. Just now I explained to you already. Okay, so if there is not enough oxygen, we do not able to think clearly. Okay, then we will lose our appetite and become dehydrated. So you are advised to drink more water, okay, when you go for higher altitude condition. Okay, so the metabolism rate also will be increases. Okay, so this will be the effects on human when you are at the higher altitude condition. Okay, so how you need to adapt yourself, okay, to the high altitude condition. Okay, so here if you are going to climb a higher mountain, okay, so what you have to do? So firstly, you need to have a physical training before the climbing. Then the second will be climb at the slow rate to allow your body to adjust in the changes of pressure. So you need to climb slower. Okay, so sometimes you need to stay at certain level before you go for higher level. Okay, so equipment such as a smart watch, they can measure the altitude, blood pressure, and body temperature should carry over together. And you need to drink water even though you not feel thirsty to prevent dehydration. Okay, so this is advice for the adaptation if you want to go for high altitude. Okay, then the second will be adaptation at aircraft. Okay, so increase the pressure in the aircraft cabin to match the sea level pressure. So as the aircraft flight to higher position, okay, so the pressure is decreases. So the aircraft need to increase the pressure inside the cabin. So by adding more air actually here. So recycle the air in cabin so that it is fresh and contains adequate oxygen level. So this is a second. Then the third, remind the passenger to drink enough water to prevent dehydration during long distance flight. Okay, so this will be the adaptation made at the high altitude. Okay, so the next here will be the effect of atmospheric pressure below the sea level. Okay, so upper the surface of the sea, there will be have atmospheric pressure. So when the divers is under the water, there is actually will be affected to another pressure. Here will be a liquid pressure lah. So using the formula H rho G here. Okay, so the pressure that added on object in water we have two. So first will be atmospheric pressure. Second will be the water pressure, where you learn already at subtopic 2.1. Okay. Okay, then the total pressure added on the object, you need to using this formula. Total pressure will be atmospheric pressure plus the liquid pressure or water pressure here lah. Okay, because under the water. Okay, so for diver, pressure that add on him will increase if he dive deeper. Or if he dives deeper, so because of the formula P equal to rho Hg, when H increases, which is measured from the surface of water. Okay, so when H increases, which is under deeper at sea level, okay, so the water level will be increases. Okay, so therefore, a diver should wear special suits to protect their body from higher pressure at bottom of sea. Okay, so here will be also related to the structure design of submarine. Okay, so you can see, okay, so the submarine go deeper position. Okay, so it will be also added by greater pressure. Okay, so that the submarine is built with thicker wall, so that able to withstand the high pressure when at the greater depth. Okay, so this is the adaptation for the diver and the submarine design to able to withstand at the high pressure when they are at greater depth in the sea. Okay, so we've already complete our all discussion about the theory of subtopic 2.2. Okay, so here we going to continue to more understand by discussion of few questions. Okay, so here will be one of the questions I take from the textbook, page 55, formative practice 2.2, question number 3. Okay, so this is the question. Okay, so what is the actual pressure at a depth of 125 meters in the dam? Okay, so state your answer in meter H2O. That means this is the first unit you need to give the answer. And then second will be pressure in Pascal. Okay, so the question given the atmospheric pressure in unit of water is 10.3 meter. Density of water will be 1000 kg per meter cube. Here supposed to be -3. Gravitational acceleration will be 9.81. Okay, so definitely for the straight, the first will be, we need to know the atmospheric pressure given as 125 meter. Given as 10.3 meter water. Okay, so here under the water is about 1 through 5 meter. So the actual pressure added on this person or diver here will be P plus P atmospheric pressure plus H lah. So here will be 10.3 plus 125 for the unit of meter H2O. Okay, so the actual pressure will be 2 water pressure plus atmospheric pressure. Okay, so the water pressure will be 125 water lah. Okay, 125 water, atmospheric pressure will be 10.3 meter water. Okay, so that means we add on these two values, we get 135.3 meter water actually. Okay, so this will be the unit in water. Okay, so for the changes in Pascal, we're using H rho G. Okay, so the H here will be this value. Okay, so the rho here will be water density, which is 1000. And then G will be 9.81. Okay, you can see substitution all value in this formula. Okay, so you'll get the value will be this. Okay, 327,293 Pascal. So this will be value for in Pascal unit. Okay. Okay, so you may also change to standard form with minimum 2 decimal places. Okay, so this will be the advice answer for this question. Okay, and then the next question will be this. Okay, so let's read the question together. Okay, so you may also show your answer in chat room. You might say you get the answer ready. Okay, so diagram shows that arrangement of apparatus is used to determine the atmospheric pressure in a laboratory. Okay, so the glass tube long or length here is about 100 cm. Okay, about 100 cm. So the atmospheric pressure is 76 cm Hg. Okay, so here, name the apparatus as shown in diagram. So definitely this is what we already learned just now. This is a simple barometer or mercury barometer. Okay, so this will be very easy. Okay, you just state the name of apparatus used here. And then the second will be the value H and K. So the H will be here. Small letter K will be here. Okay, so the H is from the surface of Mercury. Definitely, the H here represented as the atmospheric pressure. So the height here will be 76 cm. Okay, so there will be 76 cm, which is equivalent to the atmospheric pressure actually. Okay, so how about the value K? Okay, so just now we know already from the question, the length of the glass tube is 100. So from here to here must be 100 lah. Okay, so 100 minus 20 minus 76, there will be the value of K here. So we'll get 4 cm. Okay, so this is the two question. Okay, so the continue question number 3 here will be you need to determine the pressure in cmHg and Pascal in point J and K here. Okay, so J is actually at the surface of Mercury, which is equivalent to atmospheric pressure. Okay, so just now for the question, we know already the answer for H here will be 76 cm. So in unit of Mercury will be 76 cm Hg for J. Okay, so this is the J in cm Hg. You straight away can get this answer. Okay, so from changes to or converting to Pascal, again we're using the formula of rho Hg here. Okay, so the rho Hg, substitute 76 cm to meter as 0.776. Then the rho will be the density of mercury given by question, will be 13,600. Then unit G, value G will be 9.81. So substitute and press your calculator. So you'll get the value as 101,396.16 Pascal. You may also change your value to standard form, which is 1.01 times 10 power 5. Okay, so it will be 1.01 times 10 power 5 Pascal also. Okay, so now we go to the K. Okay, so the K is here. Okay, so again, here we have two values. So the H is measured from surface level of mercury, which is 20. So that means here, the point K is actually added by mercury pressure. So where here we have the weight of mercury per unit area. So here will be another pressure of mercury, which is 20 cm plus 76 cm. So the pressure in cmHg at position K, they will be 76 plus 20. So we get 96 cm Hg. Okay, then the next here will be changes to Pascal by using the same formula, okay, which is the H rho G. Okay, so the H rho G, the H we need to convert it to meter, which is 0.96. Okay, then the density of mercury is the same and G also the same. So finally you get this answer, 128,079.36 Pascal. Okay, or you can change to standard form. Okay, so this is also accepted lah. Okay, so but you can actually maintain with this not in standard form is also accepted and more accurate actually the value. And then you need to give also two decimal places with correct unit. Okay, so the next question will be what will happen to the value of H? Okay, so what is the changes of value H, which is 76 cm Hg here. Okay, so here firstly, if you lifted, okay, that means you lifted at a height of 3 cm, so that means you make it higher, 3 cm. 3 cm different from the initial. So is there any changes for the height of H here? So there will be no changes lah. If I say you still remember what you learned already at learning standard 2. Okay, so this is 1. Okay, just now we explained already. Okay, so here when lifted, okay, you lifted the glass tube, so you can see the H will be the same. Okay, so we this theory lah. So the height of mercury remain the same even though the glass tube is tilted, actually lifted up or lower down. So definitely this one lifted, they will be unchanged lah. Okay, then the second, when you tilted at the angle of 20 to right, okay, so will be also unchanged now. If I say you follow the theory we learned already here. Okay, so will be this. The vertical height remain the same even though glass tube is slanted. So that means will be no changes also for this. Okay, then the next will be lower at depth of 5 cm. So will be this case lah. So will be remain unchanged also. Okay, then the next question here will be apparatus is submerged into the bottom of leg. So this will be case of this lah. So the apparatus, okay, bring to bottom of leg. So that means will be another additional pressure added, which is the liquid pressure plus atmospheric pressure. So the H will be increases lah as the total pressure is higher. Okay, so here will be increases. Okay, then the number 5, when you bring the apparatus to mountain, top of mountain. Okay, so just now we explained it at top mountain, so the pressure will be decreases as the numbers of A decreases, collection is decreases, so pressure overall will decreases lah. Okay, then the next will be when there is a vapor. So when there is a vapor inside the vacuum space, there will be additional air pressure added. Okay, added to the surface of mercury in the glass tube. So the pressure will be decreases lah. So the H will be decreases. Okay, so this will be the changes you can see at different condition. And we actually already go through everything from learning center 1 until learning center 4. Okay, with different condition. Okay. Okay, so the next will be the last question for today. Okay, so this is a 20 marks question. So it's a Clone SPM Physics question for section C, which is involving the conception. Normally will be 5 marks and the modification will be 10 marks. Okay, so let us see the question together. Okay, so firstly here will be the diagram 11.1 shows the position of P and Q at different altitude. You can see P is at the lower position or altitude compared to Q. Okay, so here 2 identical simple barometer are placed at the both position. Okay, so the simple barometer is used to measure, okay, used to measure the pressure at respective position. Okay, so first question here will be normally theory ask you about the concept of physics or definition. So here will be physical concept. So it will be name of the physical concept involved in these 2 situations. So here we using the barometer to measure the pressure. So here is actually theory of atmospheric pressure lah. Okay, so which is the name of the side topic for this lesson. Okay, so you will get first mark. Okay, very easy. Okay, then the second question here will be the conception question. Normally will be 5 marks. Here will be the first 3 marks. Okay, so using your diagram 11.1 and 11.2, so compare. First mark will be compare the altitude P and Q. Then the atmospheric pressure surrounding the air. Second mark. Third mark will be height of the mercury column in the simple barometer P and Q. So here will be 3 marks. The first, you compare the position, altitude. Definitely Q is higher, P is lower lah. Okay, so altitude P is lower than Q lah. This will be your first answer lah. You see, you can using the symbol lower. Altitude P is lower than altitude Q, or you can using altitude Q greater than P lah. Okay, so this is a mathematics symbol you can use for answer the SPM question. Okay, so the second will be the atmospheric pressure. So the atmospheric pressure, you need to look at the H of the barometer mercury here. Okay, so you can see the first, the HP represent as the pressure height of object at P. So Q you can see is slightly lower. So the HQ is lower compared to P. Okay, so this is what you get. Okay, so the HP is greater than HQ. So that means the height of the mercury column in P is greater than Q. So this will be showing that the atmospheric pressure at P is greater compared to Q lah. Okay, so this will be the 2 answers for these 2 statements here. So first, atmospheric pressure P is greater than Q. This will be measured by the height of the barometer mercury here. This is higher. Okay, so here the height of column P is greater than Q lah. This will be the advanced answer, and very easy to get the full marks for conception question here. So another 2 questions here will be comparing the relationship between the altitude and the atmospheric pressure. Okay, so just now we know already, when at the higher altitude, so the atmospheric pressure will be Q will be lower. Okay, so higher altitude, lower atmospheric pressure. Okay, so how about density of air? Just now we actually discussed already. The density of air at sea level is more higher. At the higher position, numbers of particles decreases. That means the density of air decreases lah. So that means at higher position, density of air decreases. Okay, so this will be illustrated by this GIF lah. So you can see high altitude, numbers of particles decreases. That means the density of air decreases lah. Okay, so at higher altitude, the lower the density of air. Okay. Okay, then the next will be the 4 marks question regarding the theory. Okay, normally will be 4 marks. So here will be 4 marks actually. Okay, so using your knowledge of atmospheric pressure, explain how the liquid of the bottle can be sucked into the dropper tube. So that means you need to suck in the liquid, okay, into the dropper tube here. Okay, so how you can make it? Okay, you will be press the dropper. Okay, so that you can be moving the air inside the tube, so the pressure become lower, right? So the atmospheric pressure greater than the air pressure inside the dropper tube. So the liquid can be moved into the dropper tube. So you have to write step by step, okay, for your answer. The first will be as mentioned, when dropper is pressed, first mark, the air inside the dropper will be moving out. Okay, so when the numbers of air particles decreases, so the pressure inside the dropper tube will decreases. So pressure inside the dropper decreases. So we're comparing the atmospheric pressure with the pressure inside the dropper tube. So atmospheric pressure is higher than air pressure inside the dropper. Okay, so the atmospheric pressure pushes the liquid into the dropper tube. So this will be the advanced answer for this question. Normally it will be 4 marks. Okay, then the last question here will be the multiplication question, which is 10 marks. Okay, so let us go through the question together. So diagram 11.1 shows a submarine used by Navy to patrol the ocean. So suggest and explain how to build a submarine which can navigate with higher acceleration in water and able to control the position of water. Okay, so emphasize the characteristic of the submarine body. Numbers of propeller, so be here. How many you need, more or less? Okay, please do not give the number, more or less. So, and then the component controlling the position of the submarine in water. Actually, this one is also the theory you learn at the Form 1, Form 2, Form 3 level actually. Okay, so here 10 marks, but we just have 3 aspects. So that means one of the aspect or 2 of the aspect must be more than 1. Maybe 2, maybe 3. Okay? Okay, so you are advised, write your answer in table. Okay, so you can see here, the advanced answer here, the first characteristic here can give about 3 answer. So 3 plus 3 will be 6 here. Okay, so the body, firstly, you just learn about the relationship between the pressure when go to the greater depth in sea level. So the submarine normally will be move into the greater depth of seawater. So the pressure, liquid pressure will be higher. Okay, so the structure here must be stronger. Okay, so the material used must be strong so that can withstand high pressure. Okay, so that you can write as not break easily or able to withstand high pressure. So this is what you learned just now, right? Okay, so here is a streamline, or we can just know as aerodynamic. So just like a fish body, okay, like this shape. So able to reduce the water resistance, so that can accelerate at the higher speed. Okay, so reduce the water resistance. Okay, then the next here will be we using the material which will be have a low rate of oxidation or rusting. So that means will be not rusting easily. Okay, so does not rust or able to long lasting. Okay, then the numbers of propeller here must be more lah, so that you will be able to get greater forward thrust. Okay, so this one is related to momentum. Okay, so when momentum backward higher, so we'll be creating a greater forward thrust. Okay, so this one is related to subtopic 2.5 momentum, where you learn already at Form 4 syllabus. Okay, so we need to have more. So please do not give number for this, more or less, but here must say more. Okay, so will be produce larger forward thrust, as I explained to you just now. So the component to changes the position, there will be one and only answer. Here will be the ballast tank. Okay, so because the ballast tank can be filled out water and remove the water and change the density of the submarine. Okay, so that enable the submarine to float or submerge into water by controlling the volume of water inside the ballast tank, and subsequently will be changes the density of the submarine. Okay, so this will be all sharing for today's lesson. Okay, so that's all for my lesson today. Okay, so please click like and share of the lesson today for your friends, so that more will be benefit for this sharing. Okay, and then now I want to share to you the link e-sigil to chat room. Okay, so the link e-sigil I already sent to chat room. Okay, so please fill out completely and within the 30 minutes after the lesson end. Okay, so please don't forget to follow the next physics classes, where the non-DLP will be held on every Friday 9:30 p.m. Okay, so the next topic will be 2.4 inertia. Okay, so the group non-DLP teachers will be present to you next week as usual. Okay, then for the Form 5 Physics DLP will be as usual Sunday next week. Okay, so will be continued by Cikgu Hasnitah. Okay, so 2.3 regarding the gas pressure. Okay, so I think that's all for me today. Okay, so bye-bye. See you again next week. Okay, bye-bye.